Hello coders, welcome to our channel Level Up with Coding. Today I will discuss about the Leetcode daily challenge question, smallest string starting from lib. So the question saying about that you are given the root of a binary tree where each node has a value in the range 0 to 25. Represent the letters A to Z. This is basically smallest letters. So return the lexicographically smallest string that states the leaf of the tree and ends at the root. So lexicographically smallest, basically the string that comes first in alphabetically order is considered lexicographically smaller. As a reminder, any shorter prefix of a string is lexicographically smaller. For example, AB is the lexicographically smaller than ABA. A leaf of a node is a node that has no children. So in first example, A, B, C, D, E, D, E. So the roots are 0, 1, 2, 3, 4, 3, 4. So the output is DBA. This is basically lexicographically shorter. And in the example 2, the elements are Z, B, D, B, D, A, C. So the roots are 25, 1, 3, 1, 3, 0, 2. So the output is A, D, Z. This is basically lexicographically smaller in there. And in example 3, so C, C, B, B, A, A. And the output is C, B, A in reverse form. So this is basically lexicographically smaller. So constants are the number of nodes in the tree is the range of 1 to 8500 and the node values are 25. This is basically A to Z. So that's why this is 25. So now we are describe it in our pen and paper.
So basically the question saying about that smallest string starting from lib. Okay, so you are given a root of a binary tree where each node has a value in range of 0 to 25. That's mean representing the letter A to Z. That's mean A, B, C, D till Z. That's mean 0, 1, 2, 3 till 25. Okay, and you have to return the lexicographically smallest string. Okay, at the starting from the root till the leaf node. Okay, so just remember one thing, lexicographically string is basically just check A, B less than A, B, A, B. You can check they are A, B and they are A, B, but after that this is end, but in there this is A and B. So in lexicographically shortest is basically AB, but in the second example you can check A, B, Z is greater than A, B, A, B, Z. Why? Because you can check A, B then Z. This is lexicographically, but in there A, B, after A, B this is Z and there is A. This is lexicographically shortest. Okay, but this is lexicographically not shortest. Okay, so this is shortest and this is shortest. So how can we do this? So in this example you can check we are printing a binary tree. So A is basically 0 index and then B is 1 and then C is 2 and then D is 3 and E is 4 and D is 3 and E is 4. So basically we are denoting a global variable that is answer. Okay, so this is basically Z plus 1. So why Z plus 1? Z plus 1 basically this is the sky value, that Z is the bracket and plus 1. So this is basically 123 the maximum value. That's why we are denoting it the maximum value. Okay, and then we are using there the DFS search, depth first search. Okay, in this depth first search we are doing the depth first search. Okay, so now you can check with this algorithm how we do in there. You can check it there in depth first search. We are firstly checking this if it is a current node is a leaf node or not. So that's why we are starting from the 0, then we are come in there, then we are come in there. This is a leaf node or not? Yes, this is a leaf node. So in leaf node, what it's come with A, B and D. Okay, so now ABD. Okay, so now in ABD we are just it's pushback in the empty string. Okay, we are also denoting a empty string. Okay, you are just push it in C++. Run plus equals to and run dot pushback is same. Okay, so that's why this is the time complexity of O of 1 in C++ only. Okay, so we are just push it and then we are reverse it. So that's why ABD is basically DBA. Okay, DBA, and in answer the maximum value is 123. Okay, Z plus 1. So DBA is the minimum, so we initialize it. DBA is the maximum value. Okay, now there is any children not, so we are return in B, and now we are come in E. So now we are at the leaf node. Okay, so the value is what? A, B, E. So we are now reverse it, right? Reverse it, E, B, A, and then we are just check the smallest or not, DBA and EBA. No, this is smallest. This is the lexicographically smallest string, so this is not. And now just return, and now we are coming to the root, and now we are starting from the right side. So right side and come in there. So we are now in the leaf node. Okay, so in leaf node the it is A, C and D. Now we are reverse it, so D, C, A. Okay, so now just check, not, this is not lexicographically smallest, and is there any children? Not, just return, and then we are come to at the end point. Okay, so there A, C and E. A, C and E. You just reverse it, E, C, A. This is also not, so we are not updated. Okay, we are not updated. So at the end you just seeing that we are just return the minimum. That's also the lexicographically shortest. So that's why we are just printing it. So how we do it? First of all, we are globally initialize answer variable, that is basically the maximum value. Okay, the maximum value. Then we are also initialize a empty string that store it and then reverse. Okay, and we are doing a DFS algorithm. Why DFS algorithm we are basically using that? Because you can check, we are just do in the depth right now, in the depth, because they are saying from leaf node, so we are doing in depth. Okay, so that's why now in there you can check the time complexity is basically we are using the DFS, and we are in left and right. So that's why the time complexity is basically O of n, and the space complexity is O of n. You know it. So now we are code it. So now we are coming to our Leetcode code editor, and now I will show my code. Okay, so now we are from the string smallest from leaf function. So there we are initialize the result string to a default maximum value. Why default maximum value? Because in the tree we are initialize a maximum value. We can initialize a maximum value. So that's why result is equals to string 1 comma z plus 1. In sky from, this is basically a bracket. Plus 1 is basically the sky value is 123. This is the maximum value. Okay, so now we are perform the depth first search starting from the root with an empty running string. So that's why in DFS root comma empty string, and then return the result string. Okay, so you can check we are globally define a string result. That's I saying in my pen and paper. So now we are starting from the depth first search function traversal in the binary tree, and parameters are basically root and running. Root is basically current node being processed, and running is string representing the current sequence of characters. Now we are starting the DFS. if the current node is a leaf node or not. We are checking the leaf node. Okay, now append the current node's character value to the running string and then reverse the running string. We can reverse it now, so that's why we are reverse it, and then check if the running string is lexicographically smaller the result string or not. Just check it. Okay, then either it's smaller, then you initialize result is equals to running and then return. After that you push back it now, so running plus equals to root value plus the character, and then traverse the left subtree if it is exist, then traverse the right subtree if it is exist. Just check in the left side, then check in the right side. That's called DFS. Okay, so that's we are coded and then just submit it. Test case also accepted, then submit it. You can check it is also submitted. Okay, and this is basically 98.00 bits, so that's why we are coded, and the time complexity is often and the space complexity is also often. And thank you for watching. Please like, comment and share. Goodbye.